With integration by parts, we will be looking at the integrals of products of two different types of functions. For example, in this problem, we have the integral of x times e to the 3x dx. X is considered an algebraic term. E to the 3x is considered to be an exponential term. So over to the side, and in the previous video, I showed you how to do a ranking system. LIATE was the acronym. Whichever of the two functions ranks higher in that list, that's the one that is a good idea to let it be U. DV will be the one that's lower ranked in that list. So for this one, algebra ranks higher than exponential. So U equals X, take the derivative, du equals 1 dx. If dv equals e to the 3x dx, then keep in the back of your mind that chain rule, we have to put a 1/3 here. The antiderivative of e to the 3x is 1/3 e to the 3x. Think of it this way. If you took the derivative, it would be 1/3 e to the 3x times 3 from chain rule. That back 3 and the front 1/3 would cancel each other, taking you back to e to the 3x. The expansion is u times v, so we have 1/3 x e to the 3x minus the integral of v du minus the integral of v du. 1/3 e to the 3x dx. Our front half stays the same, 1/3 x to the 1/3 x e to the 3x minus. Now, in order to get the antiderivative for this term, because of the power having a derivative of 3, we need to incorporate or multiply in a 3 and rebalance with a 1/3. And that will give us 1/9 e to the 3x for the integral of the back term, plus c for your constant of integration. In our next example, we have the integral of natural log of x to the 4th power over x dx. Natural log, that's a logarithm. X is algebraic. Logarithms rank higher in the LIATE list than algebra, L above A. So we're going to let u be natural log of x. Its derivative is 1 over x dx. In this first step, I split the fraction up, natural log of x to the 4th times 1 over x dx. It's the same thing, I just moved it over so it would be easier to identify that we have u to the 4th du. The antiderivative of u to the 4th is 1/5 u to the 5th power plus c. Going back to the original variable, replace u with natural log x. 1/5 natural log of x to the 5th power plus c. In this example, we have the integral of x squared cosine x dx. Algebra ranks higher than trig, so u is x squared, dv is cosine x dx. The derivative of u is 2x dx. The antiderivative of dv is sine x. U times v is x squared sine x minus the integral of v du minus the integral of v du, all multiplied together is 2x sine x dx. I put some pink brackets around here in class, and because this one is still algebra times trig, this last integral we can redo with integration by parts our second round. Algebra ranks higher than trig, so u is 2x. Derivative of u is 2 dx. dv is our trig term, sine x dx. The antiderivative is negative cosine x. So only in the back half of the problem do we expand again with integration by parts. The front half stays the same. This minus sign is still the same one, but in the brackets we go u times v, negative 2x cosine x, minus the integral of v du, minus the integral of v du, x squared sine x, distributing the minus sign, that's plus 2x cosine x, three negatives on this jump. One, two, three. Three negatives make a negative. Two, sine x is the antiderivative of cosine x, plus c for our constant of integration. And then our bottom example, we have the integral of 5 arctangent of x. 5 is algebraic. Arctangent is inverse trig. I ranks a little higher than A. So we're going to let U be arctangent of x. The derivative of tangent inverse of x is 1 over 1 plus x squared dx. Our algebraic term, and notice I'm going to go ahead and move this scalar multiple of 5 out front. So our algebraic term is really just 1 dx. Its antiderivative is x. U times v, that's x arctangent of x, minus the integral of v du, so that's x times 1 over 1 plus x squared. That's the black ink. We have almost a denominator whose derivative is on top. This denominator has a derivative of 2x. Well, we only have 1x up there, but remember with scalar multiples, you can multiply in a numerical value that you need, just rebalance it with its reciprocal out front. Those blue 1/2 times 2, that's still 1, but it creates a numerator that is the derivative of the denominator. And once you do that, you can take an antiderivative of natural log of the absolute value of your denominator. So let's go back to the beginning of that. That's 5 times x arctangent of x minus 5 halves on the second jump, minus 5 halves. And because we have derivative of the denominator, the rest of this is natural log of the absolute value of the denominator plus c. Since x squared plus 1 is always positive, you can actually get away with parentheses here. But if you just want to cover all your bets, use absolute value.